Hello students, welcome to lecture series of Mathematics 1. I am Hitesh Manglani, Assistant Professor at LJ Institute of Engineering and Technology. So today we will discuss topic that is method of Lagrange multipliers of chapter application of partial derivatives. So first of all, what is called method of Lagrange multipliers? So here suppose f of x, y, z is a function of three variables x, y and z, and the variables are connected by the relation phi x, y, z is equal to 0. And suppose we wish to find the values of x, y, z for which function is maximum or minimum. Then for this purpose we will construct an auxiliary equation. So this equation is given by f of x, y, z plus lambda into phi x, y, z is equal to capital F. So here f of x, y, z is a function which is to be maximized or minimized, and lambda is undetermined multiplier, and phi x, y, z is constraint or some condition, and capital F is called Lagrange's function. So here you can see that capital F is a Lagrange function, lambda is called undetermined multiplier, phi x, y, z is a condition given in the question, and f of x, y, z is a function which is to be maximized or minimized. Now if we differentiate this equation partially with respect to x, y and z and then equating it to 0, then we will get the values of x, y, z for which function has maximum or minimum value. So this is how we can find out the values of x, y, z for which function has maximum or minimum value. Now we will discuss this concept in examples. So first example, find the minimum values of x square y z cube subject to the condition 2x plus y plus 3z is equal to a. So here first of all we will have to minimize the function that is x square y z cube. So here f of x, y, z is equal to x square y z cube. And here condition is 2x plus y plus 3z is equal to a. So this is phi x, y, z. So phi x, y, z is equal to 2x plus y plus 3z minus a. This is the given condition. Now we will consider the Lagrange's function, which is given by f of x, y, z is equal to f x, y, z plus lambda into phi x, y, z. Now what is f x, y, z? That is our given function, which is x square y z cube. And what is phi x, y, z? It is the given condition. Therefore capital F x, y, z is equal to x square y z cube plus lambda in bracket 2x plus y plus 3z minus a. Now first of all we will partially differentiate capital F with respect to x. So we will find out del f by del x. Now here let the auxiliary equation is x square y z cube plus lambda in bracket 2x plus y plus 3z minus a is equal to 0. Suppose this is equation number 3. Now differentiating equation number 3 partially with respect to x. So if we differentiate this equation partially with respect to x, then here first term is x square y z cube. So if we take derivative of x square with respect to x, then it will be 2x, because we know the formula of differentiation of x raised to n is n into x raised to n minus 1. So by that formula derivative of x square will be 2x, and here we are partially differentiating with respect to x. So y and z are constant, so y and z cube will be as it is. So it will be 2xy z cube. Now second term plus lambda in bracket 2x plus y plus 3z minus a. Now here lambda will be as it is, and here derivative of first term, and first term is 2x. So derivative of 2x with respect to x will be 2. So here it will be 2 lambda, and the second term is y, and we are partially differentiating with respect to x. So y and z are constant, therefore derivative of second term will be 0. Same way derivative of third term will be 0, because third term is 3z, and last term, that is a, which is also constant, so derivative of that term will be 0. Therefore 2x y z cube plus 2 lambda is equal to 0. Now from the previous equation, if we find the value of lambda, here 2x y z cube plus 2 lambda is equal to 0. Now 2 lambda is equal to minus 2xy z cube. Therefore, lambda will be minus xy z cube. Therefore, lambda is equal to minus xy z cube. Now, this is equation number 4. Now, differentiating equation 3 partially with respect to y. So, if we take partial differentiation of equation 3 with respect to y, then x and z are constant. So, here, first of all, first term is x square y z cube. So, here x square z cube will be as it is, and derivative of y with respect to y is 1. So, here it will be x square z cube plus lambda. In bracket it is 2x plus y plus 3z minus a. Now we are partially differentiating with respect to y. Therefore first term 2x will be constant. So derivative of that term will be 0. Now second term is y. So derivative of y with respect to y is 1. So here lambda into 1. Third term is 3z which is constant. So derivative of that term will be 0. And last term is a which is also constant. So derivative of that term will be 0. So x square z cube plus lambda is equal to 0. Now from this equation finding the value of lambda, so lambda will be minus x square z cube. So suppose this is equation number 5. Now differentiating equation 3 partially with respect to z. So if we take partial differentiation of equation 3 with respect to z, then x and y will be constant. So here first term is x square y z cube. So x square y will be as it is, and derivative of z cube with respect to z will be 3z square. So here it will be 3x square y z square plus lambda in bracket, that is 2x plus y plus 3z minus a. So here derivative of 2x with respect to z will be 0 because we are taking partial differentiation with respect to z. So x is a constant. Same way partial derivative of y with respect to z will be 0. Same way third term is 3z. So derivative of 3z with respect to z will be 3. So here it will be 3 lambda, and last term is a. So derivative of that term will be 0. So 3x square y z square plus 3 lambda is equal to 0. Now taking 3 common. So x square y z square plus lambda is equal to 0. So lambda is equal to minus x square y z square. So suppose this is equation number 6. Now from equation 4, 5 and 6 we can say that xyz cube is equal to x square z cube is equal to x square y z square, because here as you can see that in the left hand side it is lambda, so these all are same. So xyz cube is equal to x square z cube is equal to x square y z square. Now dividing this result by xz square, then it will be yz is equal to xz is equal to xy. Therefore if we compare yz is equal to xz, so from here yz is equal to xz, then we can say that y is equal to x. Now second we can say that xz is equal to xy. So if xz is equal to xy, then z is equal to y. Therefore y equal to x and z is equal to y. Therefore we can say that x is equal to y is equal to z. Substituting y equal to z is equal to x in equation 2. So it will be 2x plus x plus 3x is equal to a. So if we simplify it, then 3x plus 2x plus x, it will be 6x. So 6x is equal to a. Therefore x is equal to a divided by 6. So this is the answer of x. So we know that x is equal to y is equal to z. Therefore y and z will be a by 6. Therefore y is equal to a by 6 and z is equal to a by 6. Now as we have to find the minimum value of the function which is x square y z cube. So substituting values of x, y, z in this function. So it will be a by 6 whole square into a by 6 into a by 6 whole cube. So we can say that it will be a divided by 6 whole raised to 6. So this is the minimum value of the function x square y z cube. So this is how we can find out the minimum value of function subject to the given condition, that is 2x plus y plus 3z is equal to a. Now let us discuss second example. Find the point on the plane x plus 2y plus 3z is equal to 13 nearest to the point 1, 1, 1. So here we will have to find the point on the plane which is nearest to the point 1, 1, 1. So first of all, suppose capital D is the distance from 1, 1, 1 to any point xyz on the given plane. So suppose xyz is any point on the plane, and we will have to find the point, that is x, y, z, and d is the distance between 1 1 1 and x, y, z. So if we minimize d, then x, y, z is the nearest point to 1 1 1, because here we will have to find out the point on the plane nearest to point 1 1 1. So for that we will have to minimize the distance. Therefore, now using the distance formula, as you know how to find the distance between 2 points, so d square is equal to x minus 1 whole square plus y minus 1 whole square plus z minus 1 whole square. This is how we can find out the distance between 2 points. So suppose this is our function f of x, y, z is equal to x minus 1 whole square plus y minus 1 whole square plus z minus 1 whole square. Suppose this is equation number 1. Now this is called f of x, y, z because here we will have to minimize this distance. So if we have to minimize or maximize, then it is called the function. Therefore here function is x minus 1 whole square plus y minus 1 whole square plus z minus 1 whole square. X plus 2y plus 3z is equal to 13. This is the equation. Now condition will be pi xyz is equal to x plus 2y plus 3z minus 13. So this is the condition. Now consider the Lagrange's function, which is given by capital Fxyz is equal to fxyz plus lambda into phi xyz. So it will be x minus 1 whole square plus y minus 1 whole square plus z minus 1 whole square plus lambda in bracket x plus 2y plus 3z minus 13. So this is Lagrange's function. Now let the auxiliary equation is x minus 1 whole square plus y minus 1 whole square plus z minus 1 whole square plus lambda in bracket x plus 2y plus 3z minus 13 is equal to 0. Suppose this is equation number 3. Now we will partially differentiate equation number 3 with respect to x. So differentiating equation 3 partially with respect to x. So here first term is x minus 1 whole square. So if we take partial differentiation of this term with respect to x, then it will be 2 in bracket x minus 1. And think about second term here. Second term is y minus 1 whole square. And we are partially differentiating with respect to x. So y and z are constant. So derivative of second term will be 0. Same way derivative of third term will be 0. Now lambda into x plus 2y plus 3z minus 13. So here derivative of x with respect to x is 1 and derivative of 2y will be 0, because if we are partially differentiating with respect to x, then y and z are constant. Therefore derivative of 2y will be 0. Same way derivative of 3z will be 0, and same way derivative of 13 will be 0 because it is a constant. So it will be 2 in bracket x minus 1 plus lambda is equal to 0. Now from this equation, if we find the value of x, then x will be 2 minus lambda whole divided by 2. So this is equation number 4. Now differentiating equation 3 partially with respect to y. So here if we are partially differentiating equation 3 with respect to y, then x and z are constant. So here first term is x minus 1 whole square, so derivative of that term will be 0. Same way, now think about second term, which is y minus 1 whole square. So derivative of that term with respect to y will be 2 into y minus 1, and derivative of bracket, in bracket there is y, and derivative of y is 1 and derivative of 1 is 0. So it will be 2 into y minus 1 plus, now third term is z minus 1 whole square, so which is constant, so derivative of that term will be 0, plus lambda into here x, so derivative of that term will be 0, and second term is 2y, so derivative of 2y will be 2 because derivative of y with respect to y is 1, and third term is 3z, so derivative of that term will be 0, and last term is 13 which is constant, so derivative of that term will be 0. So it will be 2 into y minus 1 plus 2 lambda is equal to 0. Now here if we find the value of y, then it will be 1 minus lambda. Therefore y is equal to 1 minus lambda. So suppose this is equation number 5. Now differentiating equation 3 partially with respect to z. So if we partially differentiate equation 3 with respect to z, then it will be 2 into z minus 1 plus 3 lambda is equal to 0. Because we are partially differentiating with respect to z, then x and y are constant. So it will be 2 into z minus 1 plus 3 lambda is equal to 0. Because as you can see that here first term is x minus 1 whole square, so derivative of that term will be 0. Second term is y minus 1 whole square, so derivative of that term will be 0. And third term is z minus 1 whole square, so derivative of that term with respect to z will be 2 into z minus 1 plus lambda in bracket. Again derivative of x is 0, derivative of 2y will be 0, and derivative of 3z will be 3, and the derivative of 13 will be 0. Therefore it will be 2 into z minus 1 plus 3 lambda is equal to 0. Now here if we find the value of z, then it will be 2 minus 3 lambda whole divided by 2, because z minus 1 is equal to minus 3 lambda divided by 2. So z will be 2 minus 3 lambda whole divided by 2. Suppose this is equation number 6. Now putting the values of x, y and z from equation 4, 5 and 6 in equation number 2, which is x plus 2y plus 3z is equal to 13, because as we have to find the point on the plane. Now what is the equation of plane? It is x plus 2y plus 3z is equal to 13. Therefore we will have to substitute values of x, y, z in this equation. So it will be 2 minus lambda divided by 2 plus 2 into 1 minus lambda plus 3 into 2 minus 3 lambda divided by 2 is equal to 13. Now if we simplify this equation, multiplying the above equation by 2, so it will be 2 minus lambda plus 4 into 1 minus lambda plus 3 into 2 minus 3 lambda is equal to 26. So this will be 2 minus lambda plus 4 minus 4 lambda plus 6 minus 9 lambda is equal to 26. So this will be 12 minus 14 lambda is equal to 26. Therefore 14 lambda is equal to minus 14. Therefore lambda is equal to minus 1. So this is the answer of lambda. Now as we know that x is equal to 2 minus lambda divided by 2. So value of lambda is minus 1. So we will put value of lambda in this result. Therefore x is equal to 2 plus 1 divided by 2, so it will be 3 by 2. So answer of x is 3 by 2. Same way we know that y is equal to 1 minus lambda and value of lambda is minus 1. So y is equal to 2. Same way we know that z is equal to 2 minus 3 lambda divided by 2. So here value of lambda is minus 1. Therefore z will be 5 divided by 2. So these are the answers of x, y and z. So the nearest point on the given plane to 111 is 3 by 2, 2, 5 by 2. So this is the nearest point to 111 and which is on the plane. So we have found the point on the plane which is nearest to the point 111. So in today's lecture we have discussed about Lagrange method and examples related to Lagrange method. Thank you for watching this lecture. I will see you in the next lecture.